Black holes are very real.
I thought it was crazy.
I said, holy.
But what exactly are they? If we could visit one, what might we see? With their immense power, do black holes somehow shape the very structure of the universe? Is it possible we might not exist without them?
It's quite a journey.
Black Hole Apocalypse, right now on Nova. There are apocalyptic objects in the universe, engines of destruction, menacing and mysterious. Black holes. Even scientists who study them find them astonishing.
Black holes can sort of blow your mind. I'm amazed that these objects actually exist.
Black holes defy our understanding of nature.
Black holes are the greatest mystery in the universe.
They're completely invisible, yet powerful beyond imagining. They can tear a star to shreds.
Black holes actually will eat anything that comes in their path.
You really want to avoid them at all costs.
Black holes even slow time. Once thought too strange to be real, black holes shatter our very understanding of physics. But we're learning they may somehow be necessary for the universe we know to exist.
They might well be the key players in the universe.
What are these strange, powerful objects? Outrageous and surprising. Where are they, and how do they control the universe? The search for black holes is on, and it will be a wild ride across the cosmos to places where everything you think you know is challenged, where space and time, even reality, are stranger than fiction. And we're starting that journey at a very unlikely place. Here, at a remote location in Washington State, where for the first time, a radical new experiment has detected black holes. It originated over 50 years ago, when a few visionary scientists imagined a technology that hasn't yet been invented. Searching for something no one is certain can be found. The experiment is daring and risky. Failure could mark their lives forever. But they don't fail. Right here in these facilities, they make a remarkable discovery. In the early hours of September 14th, 2015, they record a message. It looks and sounds like this. Just a little chirp. But that chirp is epic, monumental. The signal traveled over 1 billion light years to reach us. It started far, far away. And what it tells us is this. Somewhere in the cosmos, over 1 billion years ago, two massive black holes circle each other in a fatal encounter. Closer and closer they come, swirling faster and faster, until finally they slam together. The black holes create waves that spread outward, just like vibrations on a drum, or ringing in the fabric of space itself. The collision creates a massive blast, putting out 50 times as much power as the entire visible universe. It sends out a wave not of heat or light or sound, but of gravity.
This gravity wave is moving its way through the universe at the speed of light.
The wave races by stars. On the young Earth, supercontinents are forming. Microscopic organisms have just appeared.
Washing over one galaxy after another, after another.
Dinosaurs roam the Earth.
The wave is still moving,
It zooms through clouds of dust.
and then it nears the Milky Way galaxy.
The Ice Age is just beginning.
We're troglodytes, drawing in caves.
Imagine a monster so massive that if you could travel at the speed of light, it would take you 71 days just to go around it once. Not 71 hours, 71 days. This isn't science fiction. This is Phoenix A, a black hole so incomprehensibly large that it contains more mass than 25,000 copies of the supermassive black hole at the center of our entire galaxy. But here's what makes this even more mind-blowing. For years, we thought we knew which black hole was the largest in the universe. We were wrong. Today, we're exploring the 5 most monstrous black holes ever discovered. Cosmic titans that challenge everything we thought possible about how the universe works. And what we found defies the laws of physics. Before we dive into these cosmic leviathans, we need to understand what we're actually dealing with. What exactly is a black hole? At its core, a black hole is deceptively simple. It's a region of space where matter has been compressed so densely that its gravitational pull becomes absolutely overwhelming. The gravity is so intense that it literally warps the fabric of space-time itself. And here's the critical part. Inside a certain boundary, the escape velocity, the speed you'd need to break free, exceeds the speed of light. Since nothing in the universe can travel faster than light, not even light itself can escape. This creates a perfectly dark sphere that we call the event horizon, the point of no return. Cross that line and you're gone forever, falling toward the center with no possible way back. Now, black holes come in different weight classes. The smallest are stellar black holes, the leftover cores of massive stars that have gone supernova. When a giant star exhausts its fuel and explodes, its core collapses in on itself. If that core weighs more than about 3 times our sun's mass, it compresses into a black hole. These stellar black holes typically range from 3 to maybe 100 times the mass of our sun. They're the most common type. Our Milky Way galaxy alone is littered with millions of them, the invisible corpses of long-dead stars drifting through the cosmic void. But black holes don't just sit there, they grow. When surrounding gas and dust get too close, tidal forces shred the material into a thin, rotating disk called an accretion disk. As particles spiral inward, friction heats them to millions of degrees, causing them to emit intense radiation, which is ironically how we detect these lightless objects. They glow from the material they're devouring. And there's another way black holes grow, by eating each other. When 2 black holes encounter one another, they spiral inward, their orbits decaying until their event horizons merge. This creates gravitational waves, ripples in space-time itself, that we can now detect here on Earth. This brings us to the giants, supermassive black holes. These monsters lurk at the hearts of most large galaxies, including our own Milky Way. They start at 100,000 solar masses and can grow to millions, even billions, of times the mass of our Sun. Our galaxy's supermassive black hole is called Sagittarius A star, and it weighs in at about 4.3 million solar masses. Its event horizon would fit comfortably inside Mercury's orbit. For a supermassive black hole, that's actually pretty modest. Scientists believe these galactic monsters played a crucial role in shaping their host galaxies, particularly during collisions and mergers. The bigger the galaxy, the bigger its central black hole tends to be. And that's where things get truly insane. When a supermassive black hole exceeds 10 billion solar masses, we stop calling it supermassive. That term just doesn't do it justice anymore. Instead, we call them ultramassive black holes, or in the most extreme cases, stupendously large black holes. These aren't just big, they're cosmically impossible. Or at least they should be, because here's the thing. These monsters are so massive, so ancient and so far away that detecting them pushes our technology and understanding to the absolute limit. So how do we find the largest black holes in the universe? Let's find out. Black holes are, by definition, invisible. They emit no light. They're literally holes in space. So how do we find something that can't be seen, especially when it's billions of light years away? The answer is, we look for the chaos they create. The first method is spotting quasars, the brightest objects in the entire universe. When a supermassive black hole actively feeds on surrounding material, its accretion disk becomes so hot and energized that it blazes with the light of trillions of suns. These are quasars, and they're so luminous that we can detect them from the